So what's driving, as I say, big data analytics is new and rapidly growing new sources of data, be that machine data from smart grids, smart meters, tags, all kinds of infrastructure in manufacturing, in telecoms, in IT, in the data center, is spitting out huge amounts of data in terms of log files, and that's only increasing at rapid rates. And you add to that the social media data, and particularly the upsurge in mobile applications creating data, things like mobile games or all kinds of mobile apps that you use. They're always spitting out data, telling the app operator what you're doing, where you're doing it, and how you're doing it, and that's a huge source of potential analytic insight for those people. And I'll talk about some use cases when I get to that. But that's what's driving it. That data is there. We can either ignore it or we can get some value from it. And the way we get value from it is twofold. There is investigative analytics, as I would call it, or sometimes known exploratory, data mining, data discovery, where you are digging around in the data, accumulating it, usually in a data warehouse, more recently often in an unstructured data warehouse such as Hadoop, and you don't know what you're looking for, so you use complex algorithms, smart statistics to try looking for correlations, looking for patterns, looking for anything that data can tell you. Is sort of an unknown unknown. And then the other kinds of insights you can get are what I've called here operational intelligence, which is the instant insights. What's going on right now? I launched a new version of my game, my mobile game this morning. How is that affecting downloaders? Are new players playing for longer? Are existing players playing for longer? Are they using the new feature or are they ignoring it? Historically, marketeers used to wait days and weeks to get feedback on their new product launches or their new campaigns. Now, if you garner that data and you act on it immediately, then you've got that information in much shorter timescales. And so, and equally, it could be things like, not just the marketing, but infrastructure monitoring. What's going on my server farm? Have I got patterns that suggest that the workload on the farm is different today than it is usually at this time? Have I got particular nodes or clusters trending towards overload, either running out of disk or being overloaded on memory or some other critical resource? All of those kinds of things. I always characterize it as saying, if you knew now what was going on in your organization, would you make a different decision? And that's the question. If you would, then you're in the market for operational intelligence. And so those two patterns, as I said, I think I've really just explained the slide already, two patterns. One is all about unstructured warehouses and machine learning, etc. And the other is about real-time decisions, often from either dashboard applications that a human manager controller is watching and looking for outliers or problems, or indeed alerting, which may be picked up automatically and then dealt with programmatically. So what does that mean? Why does big data mean anything at all? Why don't we just do it on our old relational warehouses just the way we always did? And the answer to that is the volume and the variety and the velocity. Yeah. And although a lot of people say, oh, well, old technology can't deal with the volume and it can't deal with the variety, in fact, the relational analytic engine vendors have over the last few years responded very quickly and very positively to the big data challenge, and largely they can deal with those things. You can scale out data warehouses to petabyte scale, which was thought to be only possible with something like Hadoop only a few years ago, but massively parallel data warehouses could do that sort of thing. And the real issue is that doing it on an expensive box from a proprietary vendor like Teradata or IBM or Oracle is going to be a lot more expensive than doing it on ordinary base hardware, applying open source software to that. Something like running a Hadoop cluster may be a much cheaper way to do some of those things. So it's not so much that the old technology just can't do it, it's that it can't do it cheaply enough. But also, is then Hadoop the answer to everything? Oh great, then all I need is to replace my data warehouse with a big Hadoop cluster, and I'll migrate all of my use cases across, and also I can implement all these operational intelligence use cases. Great, sorted. Yeah. But it isn't actually as simple as that, and I'm going to talk a little bit more about that. But first, let me just let's have a look at that. Be like the landscape of analytics, and it's about two dimensions I'm interested in. One is the complexity of the analytics that you want to perform, and the other is the immediacy of the results. So, as I said, Hadoop and the relational analytic databases operate in this space of potentially very, very complex analytics indeed. But if you want to do very complex analytics and you want to do that on large volumes of data, that's going to take you a long time, hours or minutes at the most to do the kinds of queries. Simpler queries, obviously, quicker than that, particularly in some of the analytic databases which are tuned for that, less so in Hadoop, which is really focused very strongly on the highly complex analytics and therefore not too worried about response times. But that map there shows a big gap. What happens for the people who want to address this space of operational intelligence? Where are the technologies for that? These are different technologies. This is where the NoSQL databases emerged around the same time as Hadoop was emerging, and they were addressing online transactional big data workloads as opposed to the more batch-oriented workloads that you get on Hadoop. They were tuned for that, but the trouble is that normally something like an HBase or a Cassandra does not include in the database much capability, not much semantics in the data. It's an object, it's a key and a value, or it's a document. So there isn't so much semantics in the data model, and so you've got more work to do. The database itself doesn't really offer you much in the way of a platform for analytics, but it's good for transactions, and I'll talk about some very use cases for that a little later when I get over to talking about use cases. And then the second kind of technology, which has been around for a long time in the immediacy of results arena, and that's the CEPs, complex event processors. They've got a long and successful history in particularly in financial services and other key domains in government, although what they're using them for is perhaps not so transparent. But the key thing about CEPs is they are all about data in motion. Databases, data stores, by definition, are places where you land the data, where you store the data, and then you process it from wherever you've stored it. It might be on disks, it might be on SSDs, it might only be in memory, but you land the data and then you process it there. What CEPs are about is stream processing, is processing the data as it goes past. So you don't land it at all. You look at the data as it comes through, you look for maybe exceptions, you look for outliers, you look for short-term patterns in the period of data that you can keep it in memory, and then you act on those, or you ignore it and the data is flushed out at the other end. And so again, there are very useful, very valuable use cases for that kind of technology, but it doesn't lend itself to complex analytics or any kind of significant analytics because you don't have access to the history. You can't say, is the trading pattern for this instrument over the last 10 minutes different from we would expect on a Tuesday morning, or different from the last 10 minutes, or different from yesterday morning at the same time, etc. So CEPs are great for where all you need to know is this thing that's in front of me a good thing or a bad thing, an interesting thing or a just run-of-the-mill thing. If you need to know more about, in order to decide whether that thing is interesting, if you need to know more and compare it to historically what is interesting for this kind of thing in this kind of situation at this time, then CEPs run into trouble with that sort of thing. That's not to say they're bad technologies, just not applicable to that. And so that is really the background first wave of big data, where you saw complexity of analytics at high volume on these new data sources were not being addressed by relational databases 10 years ago, and Hadoop emerged to deal with that. As I say, with respect to the relational vendors, I think they have responded very well to that challenge. And I think the differentiator largely with Hadoop is the cost of the infrastructure rather than anything fundamental in the processing right now. And indeed, you could see the trend. 12, 18 months ago, people were saying that Hadoop was going to replace relational databases, relational warehouses, and they were on the way out. And now, much more, you see organizations building architectures for this part of the complex analytics, which are a combination of relational and Hadoop technologies. And I think that's probably how the pattern's going to play itself out. And at the same time, as the relational vendors were too expensive and inadequate for this big batch complex analytics, we were seeing the rise of high volume transaction systems, if you like, big transactional data, things like session stores on very large e-commerce sites, where you need to keep track of the shopping basket of hundreds of thousands and potentially millions of customers online at the same time, each of them changing here, changing there, putting things in the basket, changing the amount, removing things from the basket, checking out and emptying the basket, and so on. Those are very simple transactions, but you need to keep up with those, and usually on a global scale. And it could be, and that was a typical application for people used MySQL for that a lot, but they found it quickly ran out of steam as their volumes rose or became uneconomic because of the amount of hardware you need to put under it. And you often saw the NoSQL databases stepped in and offered a simple and inexpensive, less expensive solution for the same kind of requirement, where transaction volumes were high, arrival rate of data was high, but the complexity of the processing of it wasn't particularly high. But then if you look at that map, there's a kind of an obvious gap, which is where, well, actually, I've got this high velocity data pouring through my CEP engine or pouring into my NoSQL database, but I want to answer those questions that I talked about before. If I knew now what was going on in my business, not just in the case of CEPs, simple events, if I understood what was happening now in my business in terms of the history and the past, then I could make better decisions now. And neither CEPs nor NoSQL offered that. So that was the company I worked for, and obviously you have to take everything I say with a little pinch of salt, because I'm a vendor, so of course I'm going to tell you that there's a key requirement for the technology I happen to have for sale. But vendor alert aside, I hope you will agree with me that this analysis of the marketplace is not invalid, and indeed it's because I think this analysis of the marketplace is valid, which is one of the main reasons why Acunu is in that space, because what we're trying to do is to give people the capability to deal with high velocity arrival of data, but to still be able to make decisions based on that data by using, by understanding it by insight. I'm not going to drill down and do a lecture on Acunu's marvelous technology. If you're interested in that, you've got my hashtag, you have my email, and I'm sure you can find Acunu in Google. I leave that to you if that's interesting to you. But there is the point I would like to make here, which is this where the second wave is coming, and hopefully, as I say, we propose to ride that second wave. The second wave is saying, yeah, we know about the big, the complex, the batch analytics. We need to do a better job of the real-time analytics. We need to do a better job of operational intelligence. And that's the gap, that's the opportunity. If you'd asked people 12 months ago about real-time analytics, about operational intelligence, there was almost no kind of convergence, no correlation between that and what people thought about big data. If they thought about big data, they would talk about Hadoop. If you ask people now, if you talk about analysts, you talk to vendors, you talk to certainly some of the more stretched, ambitious, challenged organizations, they are very much talking about real-time analytics now, and you see it yourself. If you do a Google search on real-time analytics, you'll see a huge amount going on of new product announcements, of acquisitions of big players seeing gaps in their portfolio. I think this is, this is the second wave as it's emerging. So that first wave, if you like, was Hadoop for the batch and NoSQL databases for low latency transactions, simple transactions, and the second wave is putting those two together, which is raising the analytic bar whilst maintaining the low latency. So back to my topics. My first topic then was to talk about technology, and now I want to talk a little bit about what drives that technology is, first and last, what people want to do with it, what questions they want to ask of their data, where that data is, and how long are they prepared to wait for the answers. Are they prepared to trade off minutes or hours of waiting for maybe a richer analysis, or can they answer the questions they want now with relatively straightforward analysis, in which case they want the answers now. So I take that map, and instead of looking at it as a technology landscape, I look at it as a use case landscape. I look at what people are doing in those areas. I'm going to spend a little bit of time now and talk about some use cases. So here's my first use case. An organization, a US organization, they sell data to retailers. Basically, they load up the shopping basket data from, I think, about 75% of all US supermarkets. Every day they take the basket data, which is what's in my basket or what's in my trolley, what are the things I have bought, and they do something called market basket analysis on that overnight, which is for retailers, it's a fairly well understood concept, but a very challenging one, because it takes a huge amount of data and a huge amount of processing to do that, and it helps them to understand what sorts of things are being bought together, and hence when supermarkets, as they do in the US a lot, present customers with coupons, money off coupons for next time they're in the store, they use Catalina's market basket analysis to tune the coupon they give to a customer, to me or you in there, according to what we bought today, what we bought in the past, and what their market basket analysis of the latest data overnight tells them are the patterns. So you can see that that's a huge amount of data. I think the biggest table they have in their database has something like 500 billion rows in it. Huge amount of data, huge amount of processing, but high value for them because, as it says there, the coupon redemption rates are as high as 24%, average is 2.5%. So that's 1,000% uplift. If there's any marketeers listening, you will, I'm sure, be prepared to sell your granny for 1,000% uplift on a campaign. And Catalina can deliver that for their customers because they can do complex analytics on large volumes of data. At the other end of that scale, there is a hospital in Toronto called the Toronto Hospital for Sick Kids, in fact. And what they do is they wire up the neonatals, particularly because obviously it being a hospital for sick kids, they've got lots of sick babies in there. They wire them all up and they monitor them with a CEP type engine, and they're watching round the clock, as I say, 120,000 messages per second coming off those babies, and they are looking, is this baby breathing too fast, breathing too low, is his temperature too high, too low, is his heart rate, is his blood pressure? Simple things, but they watch those babies round the clock and second by second, and so they can react much more quickly to a problem with a baby's health. And that's, you know, in stark contrast to the traditional image of nurse in her starched white uniform walking round, picking up the clipboard from the bottom of the cot and checking the baby once, maybe every 15 minutes. So huge value for them, and a perfect use case for what I described as CEP, streaming data technology. We don't need history to tell us that that baby's temperature is too high. We know, you know, it's a baby, their temperature should be this, it's too high. You know, it's not something that's sensitive to kind of historic patterns, it's just a fact. So that's a perfect use case for CEP. There's a company in Denmark builds wind farms, and they collect weather data from all over the world, and if a customer comes to them and says, I want a wind farm here, then they will run a simulation of that wind farm's operation over a period of years in that location based on the weather data history they've got for that location and the characteristics of the equipment that they would propose to build for that farm, wind farm. And they can optimize the design, and they can minimize the risk both of technological failure and of you know, economic shortfalls in the operation of that. Huge amount of data, 2.5 petabytes in a big Hadoop cluster. It takes hours and days for them to run one of these simulations, but it doesn't matter because it's going to take them years to build the wind farm, and the wind farm will hopefully operate for decades. So it's taking a long time to do the complex analytics in order to get the answer right, you know, simulations of the effect of weather, is worth a lot of money to them and to their customers. And back down at the other end of the spectrum, this is the use case I talked about before, the session store for shopping carts. Thousands of transactions per second, but they're all very simple transactions. That one goes into a NoSQL database. I think that's based in a London company, and they're perfectly, you know, it's a very low-cost solution, open source software on commodity hardware for a relatively simple requirement, but it's at volumes that they couldn't handle in their previous technologies, and certainly couldn't handle for an economic price in previous technologies. Another example, now this is an example of where we want rapid results. It's a high-tech manufacturing company, and they are monitoring the assembly of tech consumer goods in factories where, as for example, you know, the webcam gets fitted into the lid of the laptop, and then it gets passed to a station which will test whether the camera has been fitted accurately and the viewfinder is lined up behind the gap in the shell of the lid, and whether it takes a photograph, and then if it does, it passes on to the next one. But the test, what this company does is they collect all of those test results and then they compare them. So for example, on this batch, that machine has passed 95% of cameras, whereas on our last shift, that and the other 9 machines that are testing cameras only passed between 87 and 89%. It seems like that test rig is gone out of calibration. It's passing too many, because it seems unlikely, statistically, judging by the historic result, that that suddenly the cameras and the laptop lids have all got better and the assembly has suddenly got cleverer at doing it. So it's not a case of finding whether the camera or the laptop is faulty. You're actually checking whether the test station that's testing those things is faulty. And of course you need to know that. Maybe you don't need to know it in a second, but you want to know that now in real time. It might be tens of seconds or even a minute, but you don't want to know tomorrow when the batch is finished and the shift is over and you've assembled 1,000 laptops that are faulty, that you've got to take to pieces and reassemble the next day. That's enormously expensive to do that. So the price of a real-time analytics system on that is, rather very, very small proportion of what the savings are from that. But that's an interesting use case because it's no longer just a matter of taking the thousands of test readings per second, dealing with the high velocity data and making a judgment on it. You have to deal with it in the context of history. So this is a case, and in fact this is an Acunu customer, where we're using a combination of open source NoSQL database as the store for this, where the history and where the new arriving test results are stored, combined with the analytic platform on top of that, which allows you to apply these kinds of statistics and look for patterns and look for outliers and look for exceptions. It's not as complex as something like Catalina Marketing's market basket analysis, but it's a lot more complex than anything that you might be doing in the baby monitoring use case. So we see we're beginning to find use cases in the middle. Another one is for anybody who lives in London or indeed Toronto, New York, Madrid, Barcelona and a number of other cities, a company called Halo, which provides an app for you to run on your phone and provides cabbies with an app for them on their phone. And it's basically a dating agency for me, the prospective passenger, and for the cabbie. So I say I want a cab and I just press a button on my phone and I broadcast to Halo, send a message to Halo saying, I'm here, I want a cab. They send that message to all the cabs who are close to where I am saying, Clegg's here, he wants a ride, who wants to take him? And then the first driver to respond says, yes, I'll take that. I get a message back saying, your cabbie is Dave. This is the registration number of his cab. He's 2 minutes away. He's on his way. And here he is on the map. You can track him. It's a very simple app and very valuable. I use it all the time, as do a number of other people. What they're using analytics for is their service level agreements. Is their first application where they need to know what are the patterns in the city, where are the queues longest. They want to know are we answering all the messages coming in from prospective passengers within the service level agreement time. Are we passing them to the cabbies? Are any of the drivers habitually accepting fares and they're not turning up? Are any passengers habitually requesting cabs and then not being there when the driver arrives? All kinds of SLAs are used to monitor the network. In fact, they've been doing that successfully and they're rolling that out now in cities around the world at quite a significant rate. But the next application that they're building right now is mobile analytics for the cab drivers, so they can find out not just about how many fares they've picked up, how much money they are owed for the fares that they have picked up and delivered, but also things like where are the hotspots in the city right now where there are a lot of people requesting cabs and not many cabs answering them, and what is the average wait time where I am now versus the average wait time in those hotspots? Is it worth my while to go over there? So we're seeing, again, relatively simple analytics, but it's, and in some cases the analytics is it only needs to know what's going on now, but sometimes you need to know where there are deviations from patterns, like for example, oh, there's always a hotspot at Friday night on Victoria Station at 6:30 or whatever it is, but there's no point me going over there because it's always gone by 6:40. It gets dealt with by the local guys, so I'm not going to bother with that. But if there is an exceptional hotspot, that doesn't usually happen, so therefore there is an opportunity there, then that's going to have more influence on the driver's behavior. So another example, just like my manufacturing example, of applying analytics in real time to high-speed streaming data, and particularly in cases where you can't meet the need with something like traditional CEP, because you need to understand the history as well, and that's much more typical of business requirements. So those are my, if you like, my red use cases are the first wave, and my blue use cases are the second wave. And that's not that the second wave replaces the first wave. It's still worth waiting for the value you get from the results of that deep analytics. If you just need a simple put and get type application, for example, the shopping carts, then you want a cheap and easy and simple solution for that, and that's not going away. And likewise, the CEPs, if you're monitoring the babies, you just need the recent results. That's the second wave, the opportunity to take that real-time data, high arrival rate data, to back it with the historical context so you can understand the business patterns that are being played out in front of you and where they are exceptional today. And to do that, at high volume, and to do it in real time. Okay, that was my first wave and second wave of big data.